Good evening, Sritej.
Good evening, ma'am.
Good evening, Siddhant. Good evening, Siddhant.
Good evening, ma'am.
Good evening, Charvik.
Good evening.
Okay, let others also join. You'll just wait for 1 or 2 minutes. Okay. Okay, children. So let's begin.
Okay.
Okay, I'm sharing the screen.
Okay, ma'am. Good morning. Good evening, ma'am.
Good evening, beta. Okay, so we were doing integers, right? And in integers, we were doing some exercise questions.
Ma'am, also you gave one homework.
Oh, I gave some homework also.
Yes, ma'am.
Have you all done?
Yes, ma'am. Done.
Did you find any difficulty in doing the homework? Any question that you found difficult?
No.
No, ma'am.
You were able to do all that?
Yes.
I wait for the difficulties. Please bring your difficulties to me. Okay? If the homework was easy for you, then I must give some higher level questions to you. Okay? Isn't that? Then only the difficulties will come, no? If I'm actually waiting for the difficulties, then only the difficulties will come to me. But keeping in mind your course also. Okay, so we were at which question? Had we done this? Question number 6? We have.
Yes, ma'am.
We
Question
have.
number 6 we are done. We are done.
Have
We will do question number 8.
So 8 also we are done. I guess. No, we were doing this verify. I told you to do. I think 1 or 2 we had done. Okay.
Ma'am, we stopped at that magic square, ma'am.
Till magic square we did. Okay.
Yes, ma'am.
Okay. So you all have your books in front of you? Yes. Okay. So we'll go to the blank. Okay. We'll do here only now because we have the sum with us. Right. Yes. Saying something?
I just applied before.
Who is, yes, who's saying? Hamza, are you saying something?
No, ma'am.
Okay. Okay, now see here. Let's see this question number 8. Now this is the condition given to us. A minus of B is equal to A plus B. Now see, when we do a minus of B, when we have two signs, it automatically we get A minus and minus
Okay.
together to become plus only. So this condition is verified itself. Isn't that?
Yes, ma'am.
This condition is verified itself. But we have to try these numbers. Now, suppose if I'm taking this, A equals to 21, B equals to 18. Okay. So in place of A, I will put 21. In place of B, I will write 18. Okay. So I write 21 in place of A, then I have minus sign, and then again I have minus sign with B, like this. And on my right hand side, I can write 21 plus 18 as it is already given here. So here I have to prove whether left hand side is equal to right hand side or not. So when I do this, 21 minus and minus becomes plus. So I can write plus here, 18, 21 plus 18. So I have both numbers equal. So that means left hand side is equal to the right hand side. Okay, so this comes out to be 39.
39.
Okay.
Yes, ma'am.
Similarly, you try this one. A equals to 28, B equals to 1. Tell me if right hand side is equal to left hand side. Please do that, everyone. I can ask any one of you. And those who finish with this, they can do with 3 and second and third part also.
Ma'am, can you explain me once again as I don't know?
Okay. Now see this fourth one I'm explaining. Okay. Now in place of A, here in this equation, in place of A, you will write the value of A which is given. In place of B, you will write the value of B which is given to you. Okay. So in this condition, A minus of B, this condition, this is already written here. Okay. I'm just noting it down here. So you have 20. In place of 8, I'm writing 28. In place of B, I'm writing 11, whatever values I'm given. Okay, here also I write 28 plus 11. Now 20 minus and minus becomes plus. So this becomes 28 plus 11. And here we already have 28 plus 11. So 28 plus 11 becomes 39.
Ma'am, done all.
Okay, so this is 39. So the left hand side is equal to right hand side. Understood this?
I'm done with all of it. Ma'am, done with all the questions.
Very nice. Good.
Ma'am, I'm not getting the LHS and RHS.
What happened? What are you forgetting in this?
No, ma'am. What is LHS and RHS?
LHS is left side of the equal to sign. LHS is left side of the equal to sign, and RHS is right side of the equal to sign.
Okay,
Right
ma'am.
hand side. Right hand side. This side is my right hand, no? Okay.
Yes, ma'am.
See your right hand. Where is your right hand? So that's right,
Yes, ma'am.
right hand side. This side is left hand side. I have my left hand this side. You also see where do you have your left hand? Spread your hands and see. Okay, got it? Okay, now coming to question number 9. Okay, this is -8 plus -4. Please take out your notebooks, do it in your notebooks and find out which number is greater and which is lesser, which is equal to. Okay, -8 plus -4, -8 minus of 4. Now, I'll just show you one. The remaining you will do. Okay. Now see here. -8 plus minus. Now these two signs, when you take them together, this becomes minus. So this will become -8 minus 4, which will be equal to -12. Is that?
Yes, ma'am.
Similarly, you take here -8 and minus 4 will become +4. Okay. So here you get 4 Minus 8 plus 4 will give you
Minus 4.
2. So, which one do you think is greater? Minus 12 or minus 4?
Ma'am, right hand side.
Yes, minus
RHS.
4 is greater than minus 12, no? Because when you see on the number line, this is on the right side of the number line.
Yes, ma'am.
No?
Right.
On the number line, this is towards the right side. Minus 12 is towards the left side. Minus 4 is towards the right side. So that's greater. Similarly, try this one also. Do this. Minus 3 plus 7 minus 19. So when you have two signs together, make them one sign. Minus 3 plus, do it, do yourself. So which one is greater here? Minus 15 or minus 2?
Ma'am, minus.
Yes. Do the rest also. Done? Okay, we'll move ahead. Now see this question number 10. I won't go much deep into this question, but we'll simply just discuss. A water tank has steps inside it. This is some activity-based type of question, okay? A water tank has steps inside it. So when you are moving into the water tank, there are steps inside. A monkey is sitting on the topmost step, okay? The first step. The water level is at the 9th step. Now there are so many steps inside. The water level is at the 9th step. Now the first thing what he's saying is he jumps 3 steps down and then jumps 2 steps back. In how many jumps will he reach the water level?
8.
See, water level is at 9th step.
Yes.
So
So, he goes 3 steps front,
monkey took 3 steps down and then he moved back 2 steps.
again 2 steps.
So from here
So-
to here and then here to
So
here.
again,
11.
So that
11
means he took 3 steps down and went back 2. That means 9 plus 2 हो गया. 9 plus 2 हो गया ना? Got it?
Ma'am, can you tell again?
See, the water level is at step 9.
Yes, sir.
Okay. The monkey took 3 steps down.
Yes, sir.
Then he took 2 steps back.
Yes, sir. So, it's equals to the monkey jumped only 1 step.
Monkey jumped only 1 step. Then finally, he came back 2 steps.
Yes, sir. So, in how many jumps will he reach the
Will he
water
reach
level?
the water?
More 8 steps.
So water level is now, that means
11 jumps.
at this step he reached at water level. Why did he move back? वो पीछे क्यों वापस चला गया? He wanted to drink water now. वाटर के अंदर डूब के तो वाटर नहीं पिएगा, वाटर लेवल पे आके पिएगा ना.
Yes, ma'am.
So, so that is, I think this is 9 plus 2, maybe 11 steps. Okay. So he must be at the 11th step now. Yes.
Ma'am, we will jump 11 times continuously. Then we will reach at ninth step.
Ma'am,
Okay. Leave this. This is activity based question. Don't get confused with all this. Okay. Leave it. Okay. You can try yourself at home if you want to. Otherwise, no need. Okay.
yes, ma'am.
Huh. So these are, puzzles, riddle kind of thing. Okay. I'm moving to now properties of addition and subtraction of integers. Right?
Yes, ma'am.
Properties. Now see, in properties, you must have studied when you initially, have you studied about properties in your junior class when you were studying about natural numbers and whole numbers? Closure property, commutative property, distributive property.
Ma'am,
Have you heard
like
about
it's in
these?
the textbook, but for us it's like a deleted syllabus, so they did not taught us.
Okay, okay. Okay, so here we will again talk about that how does these properties work for integers, as you must have studied, maybe you have not studied, but it was there in the previous books. That how does these properties work on, how do they stand for whole numbers, natural numbers. Now we will study that how does these properties work for integers. Okay. Now closure under addition. What is closure property? Integers are closed under addition. Closed means what? If I say my house is open, my house doors are open only for my friends. Okay, just for example.
Ma'am is allowed.
So that means what? Your house doors are open only for your
Only for
friends.
friends.
So that means when your friend will come, you will take him in. And if anyone else comes, then you will not open the door for him. That means your doors are closed for others.
Yes.
Okay? Are you understanding? So that's how we say integers. I'm taking another page beta here. Okay? Let's do on a separate page. This we were doing sign rules. I'm taking the next page. Now we are talking about properties. Properties of addition and subtraction on integers. Addition and subtraction. So this is the topic now. Right? Now, first property that we are going to study is the closure property. See, we have different properties. I'll just tell you the names of the properties first. Closure property. Then we have commutative property.
Commutative property, associative property,
Yes.
additive identity.
That we'll talk about later. Okay. Associative property. First, we'll talk about these properties. Then we'll take the rest. Okay.
I'm distributive property.
Distributive also. Okay. Okay. Now see, closure property says that integers are closed under addition. What do you mean by this? Integers, if I say integers are closed under addition. Okay. This means that for any two integers, say I take the integers a and b. A and b are any two integers. I say that a plus b is also an integer. Okay. A plus B is also an integer. If A and B are integers, I say that A plus B is also an integer. For example, if you take 5 plus 4 equals to 9, okay, and you have minus 8 plus 2, you take any sort of integer, that also the end result will be an integer itself. Is that understood?
Yes,
This?
ma'am.
That the sum of two integers is an integer. Okay? Okay? This is what the closure property tells us.
Ma'am, what if it's like +5 and -5?
If you have minus, then also it's okay. See here, we have taken the minus also. If suppose you have minus 8, we are talking about addition now. Okay? Over addition and subtraction also we speak about. Now, if this is minus, suppose me. Now this is subtraction. Now minus 8 and minus 2 gives you minus 10. Minus 10 is also an integer. Is it? So if you suppose 5 minus 4, you get minus 1. Minus 1 is also an integer.
Ma'am, is 0 considered as an integer?
Yes, 0 also is an integer. No? Integer has all numbers. All positive numbers, including 0. All positive numbers, all negative numbers. Till infinity positive, till minus infinity towards next. Okay, and 0 also is included in that.
Okay.
So this is what the closure property says, that the integers are closed under addition. That means integers will take all numbers which comes under addition. That means when you add two integers, that is also an integer. Okay. When you add two integers, your answer is also an integer. Okay. Now in case of subtraction also you saw, okay, that for any two integers, a and b, a minus b is also an integer. Okay, you saw for addition, you saw for subtraction also. Okay. Then the next one we have commutative property. Commute. Commute means what? From here to there and there to here. Okay. Vice versa also. Okay. Now it says the commutative property says if we change the order of integers in addition, the result remains the same. That means if we do a plus b equals to b plus a, the answer remains the same. Okay. Like for example, if you say 7 plus 8 and you take 8 plus 7, your answer remains the same. Okay. Now, if you take for any negative number also, you can check 13 plus minus of 9. Okay. So, in that case also, you can see 13 plus minus 9 and you can take minus 9 plus 13. So, this gives you, what this gives you? 4 and 4. So, the answer remains the same. Okay. Similarly, you can have minus 6 plus minus of 2. Okay, and other side also you can take like this, minus 2 plus
Minus
2.
8.
You can take
Minus
plus
8
minus
minus
8 and minus 8. So order can be anything. Okay, but your answer remains the same. This is what the commutativity says.
Yes, ma'am.
Now this was, we did all addition. Okay, but is it the same for subtraction also? Now suppose if I say a minus b, will it be equal to b minus a?
No, ma'am.
Suppose if I take the number 7 minus 8, is it equal to 8 minus 7?
No, ma'am.
7 minus 8 is minus 1. 8 minus 7 is 1. So are they
1.
equal? No,
No.
not. So that means commutative subtraction is not commutative for integers. Okay,
Ma'am,
subtraction
commutative property does not come from
for integers. Okay, in case of subtraction, that means in case of
subtraction
subtraction,
and division.
commutativity does not hold true. Are you understanding?
Yes, ma'am.
In case of subtraction, we cannot say that the answer will be same both sides. Okay, so commutative property does not hold true for integers in case of subtraction. Okay, it holds true for addition. but not for subtraction. Okay, not for subtraction, not equal to. Understood this?
Yes.
Any
Yes,
who has
ma'am.
not understood closure property and commutative property for addition and subtraction? Any child who has not understood? Siddhant, did you understood? Did you understand? Yes, Siddhant, did you understand? Is there any doubt? Okay, who has written this about monkey? Siddhant. Okay. Yes, that's nice, beta. Taking monkeys, taking down steps as negative and up steps as positive. That's correct. Okay, Siddhant, I can't hear you. Are you able to understand? Closure property and commutative property? Yes, ask your doubt why your mic is not working today. Then, if it is working, can't hear you. Okay, never mind, I'll explain again. Okay, pay attention, I'll explain again. See, closure property in case of integers, it says that when we add two integers, we get the answer also as an integer. Okay, when you add two integers, your answer is also an integer. Okay, and when you subtract two integers, your answer is again an integer. This is what the closure properties say about addition and subtraction. Understood?
Ma'am, can you hear me now?
Yes, now I can hear you. So, Siddhant,
Ma'am, actually, I had a doubt in commutative property. In there, it is written that, see, ma'am, if you, in subtraction of commutative property, if you subtract two integers, it's not commutative, right? So, I subtracted many integers like that, and I got the additive inverse of them.
so see here, when I'm doing 7 minus 8, it's not equal to 8 minus 7, is it? Additive inverse is different. Additive inverse is when you add something with the inverse of the number, you get 0. That is additive inverse. Okay?
Okay, ma'am.
We'll come to that part later on. Okay?
Okay, ma'am.
We are not doing this now, so don't get confused with this. So,
Okay, ma'am.
closure property you understood? When you add two
Yes.
integers, you get your result also as an integer. When you subtract two integers, your result is also an integer. Same way, commutative property says that when two integers are added in a different order, okay, when their order is even changed, the answer remains the same. Okay, when I do a plus b and b plus a, my answer remains same. Right? This was
Yes, ma'am.
addition. Now, in case of subtraction, it says a minus b is equal to, if I take a minus b equal to b minus a, is it the same? So it is not proving the same. Here,
Yes, ma'am.
7 minus 8, it's coming minus 1, and here it is 1. So they are not equal. So that means commutative property does not hold true for subtraction.
Okay, ma'am. Thank
Huh.
you, ma'am.
Okay, beta. We'll come to additive inverse later on. Okay. Okay, now coming to the associative part. Okay, now associative property. What does this say? Associative property, here in this we have three set of numbers. Okay, A, B, and C.
Ma'am, this is simply like bracket change.
Yes, here also we are changing the order. Okay, the sum
Ma'am,
of,
it is associative in addition rate.
we'll see. The sum of three integers does not depend upon the grouping of integers. Now this says that the sum of integer does not depend on the grouping of the integers. This is how we are, if we are grouping like this, A plus B plus C. We are grouping the integers like this. This says that the sum of the integers does not depend on this. That means it has nothing to do with the order in case of addition. Okay. Now, suppose if
ma'am.
I take the example, this is let A be 7, B be minus 8, and C is 6. If I just put these values here, okay, and this is minus 8 plus C like this, and here it is 7 plus minus 8 plus C is 6. 6. So what do I get here? 7 minus 8 is minus of 1
-1.
or 6. And here if this is 7, we will first solve the bracket. This becomes 6 minus 8 is minus 2. So 7 minus 2 I'm getting 5. 6
Ma'am,
minus 2
5.
I'm getting
5.
So my answer remains the same on both sides. Left side also, right hand side
Yes.
also. Okay.
Yes, ma'am.
Now this was about addition. This about addition. Now let's see what happens when we subtract. So in case of subtraction, the same property can be written like this: A minus B minus C, and this is A minus B minus C. We just have to prove that. Now subtraction is, this says that subtraction is not associative for integers. Okay, because as we said, A minus B is not equal to B minus C. So how can this be possible? Okay, just try this. So we take an example, let A be 8, B be 9, and C is 4. Okay, let's do this. Okay, so we write here 8 minus 9 minus 4. And here also we write 8 minus 9 minus 4. Like this. So here we get 8 minus 9 minus 4 is 5. And here we have 8 minus 9, which is minus 1 and minus 4 here. So here I get minus 5 and here I get 3. So they are not equal.
Yes.
You got it? So that
Yes,
means
ma'am.
this property does not hold for subtraction.
Subtraction.
Associativity does not hold for subtraction in case of integers. All right?
Yes, ma'am.
I hope
Ma'am, what about
that was
distributive property?
distributive property also will do. Is it there in your book?
Yes, ma'am. For multiplication, it is there.
So because it holds for multiplication, it does not hold for subtraction. Okay?
Ma'am, what about the addition?
See, distributive property is different. It is like this it is. Here we have two operations in this. A into B. Distributive property says that A into B plus C gives you A into B plus A
Plus
into
C.
C.
Right.
This is two operations are here. Multiply is also happening, plus is also happening. Okay? Let me check if you have this in your book.
Ma'am,
Ma'am,
I
we
also have the
Because
old
it
test.
holds distributive property, it holds for addition and multiplication.
Ma'am, I don't understand associative subtraction.
Associative subtraction, who did not understand? Who's that? Who's saying Hamza? Is that you?
Yes, ma'am.
Okay, now see this, Hamza. In associative property, we take three integers, okay? And we group them like this. Once we group them, A plus B inside the bracket, C outside. And on the other side, we take A outside and other two inside. First, we change the order of the grouping. Then finally, what did we do? We put these values in this right hand side also and left side also, right side also. In the case of addition, we found that both the sides are equal. Okay, you understood the addition part?
Yes, ma'am.
Okay, now see in case of subtraction. Now in place of this plus sign, we had all over minus sign. So we had to prove this. Now I have just taken some numbers here, 8, 9 and 4. So in place of 8, I wrote 8. In place of B, I wrote 9, C, 4. Okay. Then what did I observe here? 8 minus 9 minus 4 is 5. So 8 minus 5, I got 3. And here it is 8 minus 9 is minus 1 and minus 4. So minus 1 minus 4 gave me minus 5. So finally what I observed is 3 is not equal to minus 5. Is it? My left hand side was not equal to right hand side. Okay. So this
Okay, ma'am.
means that commutative associative property does not hold true for integers over subtraction. Okay.
Okay, ma'am.
Understood? Anyone has a
Yes,
doubt?
ma'am.
Anyone, any child has a doubt?
No, ma'am.
Okay.
Ma'am, when will the class end?
When will the class end? This is 7:30. Your time is from 6:50 to 7:30. Okay, just 2 minutes are left for the class.
Okay.
And this monkey question, as Siddhant has written, that was a nice thing. The monkey question can be taken as all those steps which the monkey is coming down can be taken as negative integers. All the steps where the monkey is going up can be taken as positive integers. Okay?
Ma'am?
Yes.
Ma'am, going down is positive and coming back is negative.
Huh. So going up is positive, going down is negative. That means below the zero level, below the ground level, it is negative. Above the ground level, it is positive.
Yes, ma'am.
Okay, so that's just an activity-based question. You can do that. Or anytime, whenever we'll have some extra time, we'll do. Okay,
Ma'am, what is our homework?
homework. I'll give you some sums.
Okay.
Okay, now coming to additive identity. The next property, that is additive identity. See, additive identity is one property, and then you have additive inverse as one property. Okay, these are two different things. Inverse means something that is
Opposite.
opposite of other. Okay,
Yes, ma'am.
yes. So additive identity first. Oh, sorry. Additive identity. So additive identity is something that you add to a number and your number retains its identity. Any number that you add to your original number and your original number retains its identity. यानी कि वो वैसे का वैसा ही रहता है. So that particular number which is used to do this purpose is called additive identity. You got it?
Yes, ma'am.
So that means 0 is additive identity
Yes, ma'am.
in this case. Okay. If I add 0 to any number, my number does not lose its identity. Is that?
Ma'am, can you explain me again?
Yes,
I was in a, I got
Okay.
disconnected. Can you explain me again?
Oh, yes, I can do that. Okay. Integer 0 is an identity for integers under addition. When 0 is added to any integer, we get the same integer. Okay. That means
Okay.
if we add 0 to any integer, we are getting same integer. That means the integer is not losing its identity. If I add some other number to any number, okay, some number to any number, so this will become a plus 1. If I add some number to any number, this will become a minus 1. That means my number is losing its identity here, no? Okay.
Yes.
Which helps the original number to maintain its identity is called additive identity. Okay.
Okay.
And that number is nothing else but 0. All right.
Okay. Ma'am. Okay. Ma'am.
So 0 is the number which helps the number to maintain its identity in case of addition. So we call it additive identity. Okay.
Okay. Ma'am.
Now coming to additive inverse. Here you can take some examples also. 7 plus 0 will give you 7. Okay. If you have some number, say minus 16 plus 0, anything added with 0 will give the same number only. So the
Monkey.
identity of the number is retained. Okay, the number is not losing its identity. Okay, now coming to additive inverse. Okay, additive inverse. Inverse is something that is exactly opposite. Okay, the sum of an integer and its additive inverse. The sum of any integer with its inverse is 0. Okay, inverse means exactly opposite. If suppose I have some number 5 and if I add this with its inverse, inverse matlab uska opposite. If I add this with its inverse, I get 0. Okay, any number that helps me in getting 0 after adding with some number, that number is additive inverse. Okay, by adding with some number, if I get 0 as a result, then that number is called additive inverse. So here I can say minus 5 is additive inverse of 5 and 5 is additive inverse of minus 5. I can say that 5 is additive inverse of minus 5 and minus 5 is additive inverse of 5. They both are additive inverse of each other because when we add them, we get 0. Similarly, I can say minus 8 is additive inverse of 8 because when I add them, I get 0. Are you understanding, children?
Yes, ma'am.
Additive inverse means
Yes, ma'am.
opposite. If this is 5, in this other additive inverse will be minus 5. If that is 6, additive inverse will be minus 6. If that is minus 10, additive inverse will be 10. Okay. So what is the additive inverse of 0? 0 itself. 0 has no plus and minus. Okay.
Yes.
So I hope this is clear to you. Anyone has a doubt can raise your hand. Anyone, any child, Hamza, Siddhant,
No doubts.
Rayansh joined very late. Soumya also joined very late. Aishwarya, you too. See, children, please be on time, otherwise you will miss out. Okay? Although recordings are there, you can see the recording anytime, but you will miss the actual live class. Okay? So please be on time. So children, thank you for today. Thank you
Thank
so
you, ma'am.
much. Bye-bye.
Thank you.
Bye, ma'am.
You'll
Bye,
get
ma'am. Thank you.
bye
Have a
because
nice
you
day.
see
Good
your
night.
homework.
Ma'am, no homework today, right?
No, I'll give you homework. That's what I'm saying. You'll get